All right, what I thought I'd start us off with here today is talking a little bit about solving linear and quadratic equations. Maybe you know some of the techniques here that we're going to talk about, but just want to make sure that everyone kind of is on the same level playing field here. We all kind of know what we know here. And this, of course, will be helpful in future because we'll run into a lot of these linear and quadratic equations along the way. So just to make sure that we all know a little bit about how to solve them, we'll start by solving here linear equations. Of course, what I mean by that, a linear equation is just an equation where the degree of x is 1, x to the first power. So we have degree 1 equations is another way to think of this. So let's just start here and look at one. Maybe not the simplest one, but gives us a couple of things to talk about and remember. Okay, so here we have a linear equation, x to the first power. And so, of course, the goal in solving a linear equation is to get x on a side by itself. And we do that with various methods. And here's the way I look at it. The first step, of course, would be, let's go ahead and distribute, right? Distribute our 5 here. 3x minus 2 equals then, on this side, distribute the 5 just means multiply the 5 inside the parentheses. 5x plus 15. All right, then similarly, we'll have to distribute the minus, which that's understood to be a minus 1. So we're multiplying in the parentheses there by a negative 1, which of course is going to make it minus 4x plus 9. Changes the signs of what's inside the parentheses there. Okay? All right, now, once we have that, then simplify, if we can, left and right side. Of course, the left side is not simplifiable, but can't simplify yet. But over here on our right side, we've got 5x minus 4x like terms, right? So we combine those, 1x or just x. And then the 15 plus the 9, that's plus 24. All right, so once we get both sides simplified, best we can, then, like I said, the goal is to get x on a side by itself. So we're going to get the x terms on one side. And this is the way I display it, I guess you might say. If you have a different way, that's fine. Okay, so go ahead and do what you're comfortable with, as long as it works, it's correct. I'm perfectly fine with that, but all right, so yeah, we need to get the x terms on one side and then the constants, the non-x terms, to the other side. So I'm going to move this x over to the left side, and then the minus 2, or take that term over to the other side. And of course, the way I do it is do the opposite, subtract x and add 2 to get rid of the 2 then. Gets rid of the 2, makes it 0. 3x minus x is 2x, divide the like terms. Said the x's are going to go out there. That equals 26. And so we wind up with a much simpler equation. 2x equals 26. And probably, as you know, then divide by the 2. And we've got our x to be 13. That would be then our solution to this particular equation. Meaning that's the number that, back in the original equation, that's the number, and the only number in this case that we can come up with that would make this left side equal the right side, make it a true equation. All right? So that's the basics, probably one of the ones you're familiar with. what I wanted to show you too was, take a look at this one, 2/3 x plus 3x equals 7 over 6 plus 5x. All right. Yeah, so there's usually more than one way that, different order of steps that you can take. Let me show you this one because sometimes it's helpful to do what we call clearing out the denominators. If we look at the denominators, this has denominator 3, of course that's 1, that's denominator 6, and that would be a denominator 1. If we think about what would be the least common denominator for those terms, well, you got the 3 and the 6, so you're looking for the least common multiple of 3 and 6. I mean, you could just multiply 3 and 6 to get 18. However, the least common denominator, the multiple that both of those go into would be 6. It would work, if, like I said, if you just did 18 as well there. But yeah, the least common denominator would be 6. Now, if then here's what I'm going to do with that. Instead of having all these fractions in here, if I could somehow clear out those fractions, that would be to my advantage, I believe. So what I'm going to do is I'm going to take that 6 and I'm going to multiply it by both sides. Okay, and so maybe the first time out here, I'll just write it all out here. You'll see what happens, of course, when I do that. That's, that is what in equations, the golden rule of equations, I guess we might say. Do the same thing on both sides, and that's usually a legal maneuver. And so in this case, we're going to multiply both sides by 6. Well, in doing that, that again has to be multiplied by the two terms over there, distributed. And so, yeah, what it amounts to is the 6 gets multiplied by the 2/3 x and the 3x. And then over here, same thing, the 6 times the 7, 6, and the 6 times the 5x. All right. So nice things happen when we do that because, yeah, this is 6 over 1, and so you've got a 3 factor and a 6 factor in opposite, one's in the numerator, one's in the denominator, and so we can cancel, yeah, we can cancel that 3 into the 6, think of it like that. Of course, that means the 3 is now a 1, so we just have 2 times 2x, 4x, and then the denominator here is just 1. So, yeah, that's the goal of that procedure, is to get rid of the fraction. So we've done that for the first term. Now the second part didn't have a fraction, if you will, it's over 1, but so it's just multiplied, it'll be 18x. Yeah, same thing here. Really nice things happen here. Cancels the 6 out, and that just leaves me with a 7 for that term, and then the 30x is 6 times 5x. Ta-da! All right, so yeah, we've got now, no longer do we have the fractions, but we do have an equation. Same solution set. We haven't changed anything about that by doing that. And so much nicer, much easier to work with. Yeah, just combine the like terms. You got 22x equals 7 plus 30x. Okay, combine those. Go ahead and let's subtract the 30x, right? And so that's negative 8x equals 7. And divided by negative 8. And we've got our solution. X is negative 7/8. Okay? All right. So that's just a little bit about solving linear equations. We'll do a little more in a later example, but let's go here to our quadratic equations. All right, so what do we mean by a quadratic equation? When do we have a quadratic equation? Well, linear is first degree, quadratic there moves us up to second degree, right? Degree 2 x squared equations. So the largest power that we have is 2. We have x squared equation. That's what we mean by quadratic. All right, now, the thing about quadratics is pretty much on linears, there's one way you try to get the x by itself. On quadratics, there's a couple of techniques, and one technique's better for one type of equation, another technique's better for other types of quadratic equations. So that's what we're looking at. So the first technique, of course, is factoring. Factoring method to solve these quadratic equations. And as the name suggests there, yeah, we're just looking at trying to factor in on one of our sides here. Okay, now, first rule though in factoring method is to utilize factoring method, one side has to be 0, and so we don't have that in this particular quadratic equation because, yeah, we've got 6 on one side and then of course the trinomial on the other side. So yeah, you've got to make one side 0 for this factoring method to work, and so let's do that first of all. So I'm going to subtract 6 from both sides and make the right hand side here be 0. All right, so yeah, yes, then that's when our factoring will kick in. We've got a trinomial. Yeah, I'm not here going through and teaching how to factor. Hopefully you know a little bit about that. Maybe a little bit rusty, but hopefully along the way you'll get less rusty. All right, so these are actually pretty nice ones. With the x squared, 1x squared first, because yeah, what it amounts to is you got 2 binomials, 4 slots, 2 slots here, 2 slots here. The x squared, we got to factor that first, the x squared term in the first 2 slots, and then the second 2 slots, yeah, we got the minus 4. But the reason these are easy because, yeah, you can think of factors of -4 that add to be the middle term, right? Factors of 4, -4 that add to be 3. And of course, since it's a -4, we know one of them is negative. 4 and 1 is going to be the way this one works. To make a positive 3, though, I need a positive 4 and a -1 there. So, yeah, that's the way that one factors out. Of course, the check is multiplied back out, but I think you're familiar with that a little bit. So, all right. Once you've got it factored, then, what do? We take and set those individual factors equal to 0. Yeah, because 2 things multiplied together, 2 or more things multiplied together that equals 0, one of the terms in the product has to be equal to 0. So we're going to find those out, those values that make those individual terms equal 0 by setting them each equal to 0. Of course, these are very simple. Subtract 4, and you got x is -4, and add 1, you got x is +1. 2 solutions. Second degree equation in one variable, 2 solutions. Second degree, 2 solutions. First degree in one variable, 1 solution. So those typically do match up. All right? Here's another one. Let's say we've got 7x plus 4 equals 10 minus 3x squared. A couple of points to make here. First of all, yeah, we do not have one side 0, and we could go either way. We could move because they both have, on both sides we have 2 terms, so it's about the same. But here's what I would prefer, or I would suggest. Because we've got a minus 3x squared, when solving these quadratic equations, a lot of times it's best to have the x squared, if you can, be a positive. And so for that reason, I'm going to move these two terms over to the left side because I want to make that x squared term be a positive instead of a negative 3. All right, so that would mean subtract 10, right? And then add 3x squared. And of course that's not going to match up with the 7x, and I would write it first. You want the x squared term first. It would be 3x squared, and that's a positive 7x, so plus 7x, and then 4 minus 10 is a negative 6. And so that makes, doing all that makes the right-hand side be 0. Okay. All right, now, as you probably know then, now we're ready to factor, but this factoring, a little more, factoring this trinomial, a little more involved, a little more complicated. Same deal, 3x squared, factors go here and here, so just about one way to do that, 3x and x. Sometimes there's maybe more than one way to factor that term, but in this case it's just 3x and x. And it is the same deal. You got minus 6 here, factors in the second slots of each. However, yeah, we can't apply the same logic there as we did there, where you say factors of this that add up to be that, or combine to be that, because, yeah, with the 3x squared, if this is not a 1, it kind of complicates things. And there's different techniques, and if you know another technique and like it, that's fine. What I typically do is I call it kind of the OI technique, because really what we're looking at is you're looking at the O and the I of the FOIL technique. And O and I refer to the outer and the inner, right? In FOIL, you can spell it. Yeah, just look at those two things. Fairly simple, I think. All right, so yeah, we've got 6 and 1, so I'm going to try, let's just try 1 and 6, and it's negative, so one of them's negative, one of them's positive. But what I'm referring to, OI there, what I've got to check is that and that is 18x, and that is minus 1x, and of course, add those together, and you got 17x, we need it to be 7x. So that's what I'm checking those two things, the O and the I. All right, so that doesn't work. So I'll reboot here. Let's try minus 2 and a positive 3. That times that gives me negative 6. But as we see there, 3x times 3 is 9x, and minus 2 times x is minus 2x. And so you add those two together, you got your midterm. So a little more complicated, and I guess we could, could say, well, it's the same thing over here. Your O and the I have to be 3x, but yeah. It's okay? Maybe a little practice on those. You got it. But that's the way I do it. All right, so then, yeah, we've got the product equal to 0, so set the two factors into equal to 0. All right, so we add 2, divide by 3 here, 2/3. This is 2/3. Subtract 3, x is negative 3, so that's our two answers on that one. Okay? All right, so that's the, one other one on the factoring method. This is an important one too, because, yeah, a lot of times we will have what we have in the number 3 example of quadratics, and that is 12t squared minus 20t equals 0. All right, so yeah, that's for one thing, it has fewer terms, but that doesn't really have anything to do with it. What I've got here that I didn't have in my previous factoring, because if you look back at those, we'll see that we don't have what we have here, and that is we got one side 0. What we have on number 3 here, example, is we have a common factor. Let's think about the greatest common factor. of those two terms. Yeah, both of them have a t, and matter of fact, if you look at the numbers, they have a common factor of 4. Yeah, the previous, when I went to factoring on those, I didn't have that common factor, but when you do have a common factor, that is the first thing you probably want to do when you're solving these. And so factor out, in this case, we're going to factor out the 4t. And of course, that just means divide those by 4t, so it'll be 3t. Divide that by 4t, you got minus 5. Yeah, those common factors will come up, and that helps us a lot in factoring, because it makes the other part simpler. Yeah, so now, just like before, we've got two things multiplied together, so, and that equals 0. We need to set those equal to 0. All right? 4t equals 0. All you have to do there is divide by 4. Got that t is 0. Here you got to add the 5, divide by the 3, so it'd be 3t equals 5. Divide by 3, you got t is 5/3. Two solutions. Quadratic in one variable. Two solutions. Usually what you're looking for. All right. Now, the second method in solving quadratic equations, I call it the square root method. Different names for it, but square root method. Yeah, so if I take a look at a simple one, x squared equals 25. I think most of us would be able to tell there that one of the solutions here is a 5. X is 5. Well, the thing about 5 there is 5 is the square root of 25, right? So one of the answers when you have x squared equals 25, one of the answers is the square root of 25, which is 5. However, it's an x squared, so there's two answers. The other answer, if you think about it, yeah, if I plug in a negative 5, that would also solve that equation, because negative 5 squared, negative times negative gives you positive 25. Well, all right, so negative 5, of course, is the negative square root of 25. So that gives you a key there to what this square root method is. What we want to do then is, when we come to an equation like x squared equals 32, well, 32 doesn't have a nice square root, but it's really the same idea, because essentially what I want to do here is square root both sides, and that, you think of that as canceling. However, because of this, right, not only can this side be the square root of 32 positive, but it could be the negative also square root of 32. So that, kind of in a nutshell there, that's our square root method. Square root both sides, and then your number side, usually the right side, can be a plus or a minus. And that'll give you your two solutions. Now, the other thing is, typically on these, unless it's an application or something like that, the solutions on these, they typically do not want you to round off. So we need to think about simplifying this radical here, the square root. And the way you do that, and the way I think of it is, you look for perfect square factors like 4, 9, 16, 25. Look for factors like those of your number. In this case we got, well, 4 would, but 16 is even better. 16 is a factor of 32, so we're going to break down 32 as 16 times 2. Well, we've got the square root of 16 times 2, and that's why we look for the perfect square factors. We got the square root of 16, which is 4, and then of course the square root of 2 can't be simplified there, and so that would probably be the way they would represent the answers to that. I want the answers for that. Okay? Square root method. Now, one thing to note that we haven't noted yet, all right, so say we've got 2x squared minus 90 equals 0. We haven't noticed here yet, but this square root method, notice now that it's a lot different than the factoring method because I want one side to be a number. In both cases there, when we did those, but specifically here. I don't want one side 0 when I use the square root method. I want one side to be a number. What I really want is I want one side to be x squared or something squared. So yeah, if I was factoring that, yeah, that would be the way to go, but we'd run into a bit of a problem if we tried factoring it. So yeah, let's use the square root method on this. And so on square root method, you want the x squared by itself, so I want to move the minus 90 and the 2 to the other side. Kind of the opposite of what to do with factoring, but that's the way this works. So I'm going to add the 90. And so that would be 2x squared then on the left. 90's go out. 0 plus 90 is 90. And then, yeah, I want the x squared all the way by itself, so divide by the 2, we've got x squared equals 45. Yeah. So now, yeah, it's just like the one we just did. So square root method works well. Square root both sides. The number side could be a plus or a minus though to get the two solutions. Those cancel. Let's see, 45. That's look for perfect square factors. 4 is not, but 9. 9's a factor there, so I think that will work there. So it'd be plus or minus. You got the square root of 9, which is 3, and then square root of 5. Take that on there. Okay? Plus or minus 3 times the square root of 5.